Hey guys, here I am again, finishing up this 6 weeks 3 test review, and I want to go over the last parts of it with you. Hopefully this will be the last section of these videos, and we're going to start off with lesson 7.9D, and it tells us to list the steps used to find the total surface area of a rectangular prism. Well, the steps are, number 1, we're going to find the area of the 6 rectangles. A lot of times this is really easy to do if it's a cube, if it's that specific rectangular prism where all of the sides are the same and we have a cube, then that means you only have to find the area of one side and multiply it times 6. The rest of the time, if you folded this into the shape, the front and the back would be the same, the side and the side would be the same, and the top and the bottom will be the same. So really you're only finding the area of 3 different rectangles and then multiplying those times 2 and then adding it up together. So, but finding the area of the 6 rectangles, and then the second step is add them up. And then you'll have the total surface area. Okay, second question. The figure below is a net of a rectangular prism. What are the dimensions of the prism? Well, 8, 18, and 18. Okay, 8 by 18 by 18 inches. What is the total surface area of the rectangular prism? Well, if this is 8, then we know that this is 8. So this is 18 by 8, this is 18 by 18, and we're going to work this out. Let's see. Come over here. There are actually 4 rectangles on this one that are 8 by 18. That's the top and the bottom of this prism, and then the side and the side. So whenever we get 18 times 8, we can multiply that times 4, and that'll tell us what almost the whole thing is, and then we just have to figure out what the front and the back are. Okay, so 18 times 8. Well, 8 times 8 is 64. Oh, 144. Okay, and again we said that there is the top and the bottom and the side, so we're going to multiply that times 4. 4 times 4 is 16. 17, 576 for those 4 sides, and then including the front and the back, we have 18 by 18, so we have 4 of those and 2 of those. Remember, there's always, for a rectangular prism, there's always going to be 6 sides all together. So 18 times 18. We actually already did that multiplication up here on this last question, so I can just find my answer from there. It's 324. I'm going to transfer that to here, 324. And there's 2 of them, so I'm going to multiply this 324 times 2. 2 times 4 is 8, 4, and 6. So, since we're looking for the total surface area, we're going to add that all up. The 576 plus the 648 will give us our total surface area of 8 plus 6 is 14, 12, there we go, 1,224. Its area, so it's 2-dimensional square inches. Okay, moving on to the next question. Where did I put page 8? We had this in order before I started the video. Oh well. Number 3, describe the faces of a rectangular pyramid. Okay, so when you have a rectangular pyramid, and this is an example here, you have one rectangular base and then 4 triangular faces. Okay, move that down a little bit where you can see. Do the heights of the four triangular lateral faces have to be congruent? The answer to that is no, because sometimes you will have something that looks like this. Oops. And if it looks like this, and this is the top, okay, the distance from here to here is way shorter than the distance from here to here. You see? So the heights of the four triangular lateral faces do not have to be congruent. Okay? The last question here, draw a net of the rectangular pyramid below and then find the total and lateral area for the pyramid using the net. Okay, so the first thing I'm going to start off by doing is taking this box that's on the bottom, the rectangle. I'm going to draw that rectangle, and it's 16 by 12. See that? That's where I got those numbers from. Now I'm going to peel down each triangle. I've got a triangle on the left side, a triangle on the right side, and that has a base of 12, and the height of the triangle is this distance right here, which is 21.5. 21.5. Okay? And then we have the front and the back of the triangle, and we know the base of the triangle is 16, see, but the distance from here to here is going to be my height. So 20.9. And we know, I know that my drawing's not too great, but this front and the back have to be the same, and this side have to be the same, okay? Because they're all going to meet whenever you fold them up into this little peak. Alright, so it wants us to do two things. It wants us to find the total and the lateral area. So let's start off by finding the lateral area, and then we can add the area of the base to it, and we'll have the whole thing. Okay, so let's start off with this. We know it's 12, and we know that the height is 21.5. So if I use my area of a triangle, base times height divided by 2, the base is 12, the height is 21.5, and divide that by 2. So if I do 12 divided by 2, I get 6, and 6 times 21.5 is the answer. So come down here, 21.5 times 6. 6 times 5 is 30, 9, and 12, and bump it over 1, so I get 129. So the area of this is 129, and the area of this is 129. Okay? Now I'm going to go to these triangles, and those triangles are 16 by 20.9 is the height. So area formula, base times height divided by 2, plug and chug, put a 16 for the base, 20.9 for the height, and then divide by 2. So now I've got 16 divided by 2 is 8, and 8 times 20.9 is, I don't know, 20.9 times 8. 8 times 9 is 72, 7, 16, so that gives me 1,672, and I gotta put a decimal here. I was like, that's an awfully big number. That would be why. You had to bump it over 1, 1. There we go. So 167.2. 167.2. So we've actually found the area of all of the lateral faces now. So we can find the lateral surface area by adding up all of those numbers, 129 plus 129 plus 167.2 plus 167.2. So if I add this all up, the 0.2 and the 0.2 gives me 0.4, and then 7 plus 7 is 14, plus 9 plus 9 is 18, and 14 is 32. Carry my 3, 9 plus 6 is 15, plus 2 and 2 gives me 19, carry my 1, 1, 2, 3, 4, 5. Okay, so the lateral surface area is 592.4, and this is square units. And then, after we find the lateral surface area, then finding the total surface area is just a matter of adding the area of the base to the lateral surface area, because we've already found all of the surface area except for the base. And so the base is 16 by 12. The bells are working. 2 times 6 is 12. 1, 3, 0, 1, 6, 192. So if I add 192 to the total surface area, then I will have, to the lateral surface area, I will have the total surface area. Woo! So that 0.4 is in its own thing. There is no point anything here, so we leave that alone. And 2 plus 2 is 4, and 9 plus 9 is 18, and 7. So 784.4 is my total surface area. Okay? So I've got 2 answers here, the 2 things that it asks for. The lateral surface area, boom, the total surface area. Okay? Boom, boom. Alright, kiddos, let's move on to page 9. We have a new topic here. This is lesson 8. It says below is a dot plot representing the number of minutes a group of 7th graders spent on a science project last week. So we got 40 minutes, 45, 50, 55, 60, and 65. What percent of the students spent less than 50 minutes on the project? So remember, percent question is going to be the part over the whole equals the percent over 100. So let's write that down. Part over whole equals a percent over 100. So the part is going to be number of students that spent less than 50 minutes on it. And 50 minutes, this is actually less than 50 minutes. So we're looking at these 4 kiddos right here. So the part is the 4. The whole is the number of students altogether. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 4 out of 15 spent less than 50 minutes on the project. But the question is what percent. So instead of a percent right there, we're going to make that our unknown. That's X right there. Okay? So when we cross multiply and divide this, we get 400 divided by 15. So cross multiply that, you get 400 equals 15x. Divide both sides by 15, and x is equal to whatever that is. So I'm going to come up here where I have some space and divide that. 15 goes into 40 2 times. That gives me 30. Bring down my 0. 15 goes into 100 6 times. 6 times 15 is 90. And I'm going to get a 1. And so it doesn't say for us to round it off, but I'm going to go ahead and do that so it doesn't take us very long to do this. We get a 0 there because 15 does not go into 10, but it goes into 100 6 times. Sorry, I put that in the wrong spot. And that round to 26.1%. So 26.1% of the time you have a student that's spent less than 50 minutes on their project. Of the students who spent less than 55 minutes, what percent spent 45 minutes? Okay, so this is the whole, and this is the part. Okay, so the part that spent 45 minutes is 2. This question is a little different because it's redefining what the whole is, because most of the time you think the whole is all of them, but this is talking about only of the students that spent less than 55 minutes. So we have to say 1, 2, 3, 4, 5, 6, 7, 8. These are all the students that spent less than 55 minutes. So there's 8 that did that, and that is equal to X, my percent of 100. How about I show you what I'm doing? Yeah, sorry. Okay, so you should be able to look at this and say, 2/8 is the same thing as 1/4, and 1/4 equals 25%. You can't do that, then we need to be studying our real common numbers that you have to change. 1/4, you got to know, is 25%. Okay, what's the ratio of the number of students who spent less than 50 minutes to the number of students that spent more than 50 minutes? So that would be a dividing line right here. 50 to more than 50. Okay, we're not actually including 50 at all in this. We're comparing the ratio of these students, 4, to these students, 1, 2, 3, 4, 5, 7. So that's a 4 to 7 ratio. Okay? You can write it in all of the different ways that you write ratios. 4 to 7, 4 to 7. But probably what you're going to see on a test is this ratio, the fraction. Okay? All right. Lesson 9. What is the population used for data gathering? That is a sample. What do you need to consider when choosing a sample? You need to consider bias. Okay? Bias is if your group is likely to choose something because of where you're at, or the makeup of the group, or something like that. You need to make sure that your sample is random, so that the results that you get for your survey are not skewed because of a bias in your group. Anyway, number 3, Mrs. White was buying a dozen eggs. She always opens the egg carton and looks to see if any of the eggs are cracked. She had to open 4 cartons before she found one that had 12 eggs that none were cracked. If the egg storage area of at the store has 80 dozen eggs, how many would you predict has cracked eggs? Okay? So we're going to say part to whole equals part to whole. Okay? Over here we're going to do our experiment, and over here we're going to figure out the prediction. The part that were cracked out of the original 4 cartons, there were 4 cartons, and she found that one of the only one of them, there it is, had 12 eggs, that none of them were cracked. So the part is none are cracked. And then the whole, wait a minute, how many would you predict have cracked eggs? So, never mind. The whole is going to be cracked and uncracked cartons. And we're going to put cracked cartons of eggs up here. So if one of them was not cracked, that means that 3 of them were cracked. Okay, so 3 out of 4 are cracked. And the question is, if there's 80 dozen eggs, how many of them were cracked? Would we predict would be cracked based on the 4 that we've looked at already? Well, if 3 out of 4 were cracked, then X out of 80 are going to be cracked. So you could cross multiply and divide this and solve it. Or if you realize that 4 times 20 is 80, then you know 3 times 20 would be 60. Okay? If you can mental math it that way, that is so awesome. But if you can't, that's okay. 4 times x gives me 4x. 80 times 3 is 240. When you divide both sides by 4, you get 60 that way also. So it's okay. 60 cartons would be cracked. 60 cracked cartons. Yeah. All right. And the very last page of our review, number 4. A survey was done to see how many dogs the students in the middle school had for their pet. Look at the circle graph below. Each sector of the circle is identified by the number of dogs and the number of students. How many students participated in the survey? Well, 5 plus 3 plus 4 plus 8 plus 10. 5 plus 3 plus 4 is 12, plus 8 is 20, plus 10 is 30. So that's 30 students. If the middle school has 500 students, do you think this is a large enough sample? 30 students out of 500 students? Yes. If all of the students surveyed were 7th graders, would that be a good example? No. Oh, it said explain. The sample should be random. What percent of the students surveyed has 1 dog? Okay, so part over the whole equals a percent over 100. So part over the whole equals a percent over 100. The part is going to be the numbers that has 1 dog, and 8 of them has 1 dog. Okay, the whole number of students was 30. The question is what percent, so that's my unknown. And now I cross multiply and divide this and I get my answer. 30x equals 800. Divide both sides. Cancel out those zeros and I get now 80 divided by 3. 3 goes into 8 2 times. 6. Oops. Uh-oh, I'm going to have a repeating decimal. Okay, so 26.6%. If I round that up, that would be 26.7. So 26.7% have 1 dog. And we're going to put a wiggly equal sign because it's not exactly. I rounded it off. Okay, and then the last question, what percent of the students had more than 1 dog, had 3 dogs? What percent of the students had more than 1 dog, had 3 dogs? Okay, who had? Read, Miss Page. All right, so again, we're changing our whole. So the ones that had more than 1 dog would be, let's see, it's not the 0 and it's not the 1, so we're going to cancel out those, and it's 3 plus 5 plus 10. That means that there are 18 kiddos who had more than one dog. Okay, and then what percent of them had 3 dogs? Well, 5 out of 18, and then my part over the whole. The question is what percent? And that 100 is the easy one. Okay. Let's cross multiply this. 18 times x equals 500. All right, kiddos. Divide 500 by 18. 18 goes into 50 2 times. 2 times 18 is 36. 14 and a 0. 18 goes into 140. 7 times. 7 times 8 is 56. 7 times 1 is 7, plus the 5 gives me 12. And I have a 14 remainder. And then we're actually going to have a repeating decimal again. 27.7 this time. So if I know that that repeats, if I round that to the 10th place, then it's 27.8%. It has to round up. So show that, and x equals 27.8% of the students who had more than one dog had 3 dogs. Whew. Of the students with more than one dog has 3 dogs. Alright guys, I hope I did a good job of explaining to you how to do these things. If you still have questions, be sure to talk to your teacher. Do your best on the test, and that, my childrens, is the end of our review. Okay, have a wonderful day. Bye.